Hi everyone! Today we'll be building face recognition system using OpenCV, Python and few Python libraries. I'm sure it will be fun and helpful project because we'll be going through 3 steps to build our very own face recognition system. First of all, we'll be importing required libraries for this project and load an image, basically face of a person. Then we'll be loading a test image to plot it. Then we'll compare them whether they are similar or not and get a similarity score. Before getting started, I would like to say that to get most out of this project tutorial, I highly recommend to do 3 things. First one is pause the video for 5 seconds. Second is start the project yourself on your device, whether you are using Google Colab like me or using local environment. Then come back and replay the video to follow all the steps along with me. In that hands-on way, you will be building your very own face recognition system, and then you can add it to your resume or portfolio and show it to your potential employers. I will show you everything step by step. Also, I would really appreciate if you could subscribe and like to see more videos like this in the future. We will be using Google Colab for this project, which is a hosted Jupyter Notebook service that requires no setup to use and provides free access to computing resources. If you do not have a Colab account, you can access it totally freely by signing in with your Google account at collab.research.google.com. I'll put this link in the description box below. So let's get started. First off, I want to say that for most of computer vision projects like this, we have to change runtime to GPU from here like this. Or if you have GPU in your local machine, you can change it from here, change to local runtime. Now we are ready to install face recognition libraries through pip. The face recognition library is a popular Python library for facial recognition tasks. One of the main advantages of this library is its ease of use. It allows us to perform complex face recognition tasks with relatively simple code. First, let's import OpenCV. This actually brings into OpenCV a big library for working with images and videos in Python. Let's also bring in NumPy, which is like really helpful when we are working with numerical operations in Python. It's really great for working with arrays and metric operations that we'll be seeing in the later part of this video. I think I already explained about face recognition, and let's go to the next part. This helps us to manipulation of images in Python. PIL is actually Python imaging library. And let's move on to the next one, import requests. This line helps us to make HTTP requests to get data from the internet. That will be a link to fetch the data, to fetch the photo from the internet. Then let's also import this one and Matplotlib. This is a library for making graphs and showing images that will show our results. Now, what we are going to do is select some face images to compare. I looked up to the internet and let me paste links here as a note. Let's use celebrity pictures to compare. Let's open up these links. Let's also open up this one. And Emma Watson's one. Yeah, so we'll be using this as our main picture, and this is a test picture, and this also a test picture. Like we can see that if it gives a false signal to us or not. Then let's come back and try loading the image from the web. First, this actually uses a request library to fetch an image from the web, like request library that we have just imported earlier. We give it a URL and it gets the image from that address. Then we have this line. This line is about opening the image we just downloaded. Image.open is from the PIL library and opens the image. And bytes.io response.content part, this part takes the data we got from the internet and makes sure it's in the right format for the image.open to work with. So let's run this. So we have successfully loaded our image and can move into the next step, which is converting the image to format a suitable format for face recognition library and OpenCV. First off, we have to change our image format to NumPy array. Then we'll be changing image color format to BGR blue green red format from RGB red green blue format. The reason for doing that is BGR is color format that we can work with OpenCV. Before running this cell, let's also convert the image format back to RGB to display using CVT color method from OpenCV library. We put another new variable for that here. Let's run this cell. Now let's see how we can display our processed image using Matplotlib, a popular plotting library in Python. First off, let's look at this line. This line tells the Matplotlib to display the image. IMG and RGB is the image we prepared earlier, now in the right color format to display. Next, plt.title. This adds a title to our image when it's displayed. We are naming it Anna Hathaway as it's Anna Hathaway's picture. Then let's go to here. This actually removes the axis numbers from around the image. It makes the display cleaner, focusing only on the image. Finally, plt.show. This command actually displays the image on the screen. It's what brings up the visual output of our script. So let's run this. Cool. So we managed to process our image successfully. Next thing we are going to do is to find the location of the first place in the image and create a unique encoding for that. First, let's go to this line. This line finds the location of the first face in our image, and face lock will have the coordinates of that face. Next, encode Anna. Here, the script creates a unique encoding for the first face it found. This encoding represents the features of the face in a way the computer can understand. Then the last part, the print face lock part, is simply prints the location of the face we found. It's a way to see coordinates of the face in the image. So let's run this. Great! As you can see, by just importing face recognition library, we could find coordinates of the face in the image. So let's go to the next step. Next thing we'll be doing is let's try finding all the face locations in the image, and let's also try returning an array of rectangles where faces were found. First off, face locations. This line used our face recognition library to find every face in the image. It saves their locations in face locations. Moving on, let's come here and let's create a loop. We have a for loop. This goes through each face location we just found. For each face, the script will do something special. Inside the loop, as you can see, this line gets the coordinates of the current face, its top, right, bottom, and left edges. Then the last line, here we draw a rectangle around the face. We use coordinates, choose a green color, and set the thickness to 20. Let's run this. Fun part. Now we'll be displaying our first image with face detected. Let's first change the image color back to RGB. And also, let's display the image with Matplotlib. Let's run this. Wow, we've done it! We've detected face in our first image. Now we can go to the part 2, which is loading our test image. In the part 2 of this video, it's quite tricky here. We'll be just doing the same things as in the first step, but we'll be using test link and different variables. Let's see it here, so let me just paste the code from previous part. Here, as you can see, it's almost identical, but with a different test link here. As you can see, let's check it. Uh, it's an Hathaway test photo, as you can see. And we have used the different variables, image test, face lock test, and so on. So let's run this. Cool. So we could detect face for other image as well here. Now we can move on to the next last part. Next, in part 3, we'll be comparing our main target image and test image. Let's have a look at these lines. Here we have first line. This line is crucial for face comparison. It takes the encoding of Anne Hathaway's face and compares it with the encode test, which is the encoding of another face we are testing against, the second image. If you are wondering why there is this kind of bracket here and this doesn't, well, here encode Anna, this one is our main target image and this is the test image that we are testing against. So that's the reason for that. And compare face function actually helps us to do that comparison. The result is stored in the results. So let's print results here. Whoa, this is so great. Even though these faces are in totally different environments, it could detect it. In one photo, Anna is smiling, and in the other one, she's not. Also, I think test image is an image when she's younger, even though that it could detect both images are same person. This is so cool. Alright, so now we know that they are an image of a same person. Now let's see how similar they are with the help of these few lines of code. Let's run this. Well, we should come up with a score. Yeah, this score here can take values from 0 to 1, and lower this score is that it means they are similar, and higher that is close to 1, that it means they are different. But as you can see from here, it's recognizing that our two images are most likely same person. Now, last thing is let's print text to our image here. So in this code, actually, we are doing some fonting and giving a color here and selecting the thickness of 2 and just turning the image color back to RGB using the CVT color method like just we did earlier and displaying the image with Matplotlib. So let's run this and see how it goes. Now you can see that we added the text here, it's giving a value of true, which it had before. Before wrapping up this project tutorial, I just want to show that last thing, that what becomes if we change a test link here to Emma Watson's photo instead of Anna Hathaway's another photo. Let's try doing that here. Let's come over here when we just include our links. Let's copy this link. Let's copy this. And let's come back here to test photos when we loaded it. Let's paste it here. Let's run this. Cool, it's displaying Emma Watson's photo. Now let's go to our next cell. Let's run this. It's returning false as expected. As we just saw earlier, it returned true for Anna Hathaway's another photo. Let's see how different they are. It's like 78, 0.78. So let's go to the here. Now it's with a false 0.78 with the Emma Watson's photo. You can even try different celebrities' photos here. Like let's look up for some celebrity photos, celebrities. Let's come over here, image, and maybe she looks like Anna Hathaway. Let's open the image in new tab, and let's copy this link. Let's come over here, and let's paste it. Let's run this. So it's going well. Yeah, it's returning false because it's not Anna Hathaway. Yeah. So this code. Thank you very much. If you are here until this part of tutorial and following all the steps with me, you've done it. You have built your own face recognition system with OpenCV and face recognition libraries. Congratulations! And if it was helpful, I'm really happy for that. But before moving on to close this, I would like to see which part of tutorial you liked. Could you comment in the comment section below which part you liked so much? Also, it would be so helpful if you subscribe and like. As always, thank you very much.